We're going to get the bearing shells made for the cement mixer bearing blocks here. Alright, in the previous video we machined up these bearing blocks from basically raw castings. They were never machined as they came from the cement mixer. They were just ground on, and now they're fully machined, both sides, bottom, and the inside. So we have a nice round bearing block, and all machined to fit really good. We just need to make some bearing shells. And we're going to make those. This is 932 bearings bronze. Cut off a chunk of this. It's 13 inches long, 3 1/4 in outside diameter, 2 1/2 inside diameter. And we're going to cut off 6 inches of it. We'll be able to get the two pieces out of that and still have something to hold with at least. So here we go, the 6 inches of materials in the lathe. I just threw it up in there. It's within 1/1000 to run out, which is fine. We got quite a bit to take off. I think I'm going to bore it first to rough diameter ID, and turn the OD, and then finish bore it. I'm going to cut the felt grooves in there, and we'll just cut it off. We'll part it off. Pretty much that'll be about it for the lathe. The rest of it will be mill work. Got a 1-inch boring bar in here, and it has a 1/4 inch tool in it. I'm going to go in there 2 1/2 inches and see how this cuts. We'll just see how it goes. That cuts it okay for a rough tool, for roughing it. We're probably going to change it for probably put a little bit different grind on it for a finishing tool, but for roughing tool that is going to work pretty good. All right, I'm going to stop right there for the roughing. Within 40 thousandths of diameter. All right, we marked the length. All right, I've changed over to high-speed steel. With the carbide, I was running about 2 to 3 thousandths of taper. One cut with the high-speed steel, I have 2/10 of taper now. Carbide has a lot more push as far as tool pressure goes, usually. So that's a big difference, right? And so the sharpness of your tool in high-speed steel, this is a perfect example of how it will cut and not give you so much tool pressure. Where carbide, unless you sharpen it yourself to a nice fine edge, you'll get that tool push, the tool pressure. You need to watch for that, I should say. You should check your work and watch for that. But especially in this type of materials, your sharp high-speed steel works extremely well. We're going to finish up this OD, and then we're going to finish up the ID. 723 is my target on this, and see what we got here. 723.15. Oh, here you go. 723.10. Pretty nice bearing so far, right? And we're going to put in the felt ring grooves. I'm going to use this inserted grooving tool. It's 80 thousandths wide, so I'm going to flush it up with the end, go in 100, and then go to 250, and we're going to go 60 thousandths deep. This is the parted end. Now we'll go do the other side. Now I'm just using my lathe, my magnetic lathe DRO setup to do this. These aren't that critical. But I have OCD, so now I'm going to knock out that center part that's in there. Now I have my boring bar sticking out quite a bit, and that was so I could film this a little bit better. And I'm just going in and going across it to make it really nice and smooth. Otherwise, I'd have a little short boring bar here, and the blocks would be here. You couldn't see anything. So that came out really nice. Now I'm just going to flip it over and do the same thing. It's just instead of trying to reach in there and see what I'm doing. Came out real nice. Now, if you're thinking about concentricity, that's within a half a thousandth or less. I dialed the chuck in real good in the beginning, and these are all machined, and I've actually checked it just to let you know. So that's one of the big advantages of having a just true chuck and a 6-jaw chuck. They're very accurate, especially on a machined part. good. In the first video I talked about being able to squish the bearings in and whether I could get to that, achieve that or not. So that's what I was shooting for, is to be able to squish them in there, not so they're loose, right? So here you can see how that just sits in there, and there's this about a 1/16 of an inch gap. Now if I squeeze that, see how that goes perfect in there? Nice tight fit. That's what I wanted. That kind of crushes it a tiny bit. Now, when these are said and done, the recommended clearance inside here on the journal for this size journal is between 5 and 7 thousandths. It's really actually quite a large gap. So being able to squish this, I turned this to the exact size of the journals, so we might be a little tight, but it probably won't be too tight. So that's what we're shooting for. Anyway, so this shell will go on there, and it just, I can press this together with my hands. Just squeezing it. That's the fit you really want. That slight crush in there. That came out just awesome. Now we're going to cut that, and we're going to cut about 55 thousandths out of there. That's the thickness of my saw to cut that I'm using, and that's why I used a 50,000 shim, and they should just come together perfect. Now this one over here is the same. Just goes together perfect, just like that. Just pushing it together like that. I'm really happy with that fit. All right, we're gonna set this up in the vise on a 1, 2, 3 block, like so. All right, it's on a 1, 2, 3 block, nice and tight. Now we're going to come over here and just figure out where the top is. We're going to come down halfway and half the thickness of this, and we're going to cut it right in the middle. We'll cut one side, and then we're going to come around. Yeah, it's just barely touching, so we'll call that 0. Now I slipped in one of these 50,000 shims, and I clamped it this way. This will stop it from wanting to fall onto the blade as I cut through. This should hold it in place a bit. Just so as I cut through, I can just shut the machine off and then remove the saw. That way it won't drop on the blade and toss the part or break the blade or whatever. This will kind of hold it in place, squeezing it. I can remove it, and it stayed perfect in location. So it stayed perfect in location. We'll loosen this up, and there it is. Just right. Not too bad of a finish even. Pretty smooth. Just little burrs, but nice. Stuff cuts pretty easy, and it throws a nice chip out, so it cuts real nice. Alright, we're ready to put the shells in place on in the housing, and these have an absolutely perfect fit. You actually push them down a little bit, and they came out real nice, and they're just a few thousandths maybe when it's evened up here below the surface, which is just fine. They don't have to be flush. Heck, they could be an eighth of an inch below the surface, really. But they're close. That's really good. I did not even try to get them so they'd be flush on here. I didn't measure this or anything as far as the height goes. It's just not worth it. But they're within a few thousandths. And they're a little bit wider. I made them a little wider than the block. So I'm just going to even that up by feel each way. So it's about, sticks out a tiny bit past the block. That way if something hits it, it hits the bearing instead of the block. Now I made up a couple little screw-in spacers from socket head cap screws to go in here to support a parallel. So I just screwed them into the T-nuts. And then I have a parallel that's 5/8. It fits in here perfect. And we're just going to set that on top of there so I have a solid fence. Then we're going to take this is a 1-inch parallel, and we're just going to set that right there. And that is going to hit the machine surface of the bearing block. We'll set this on here. Now, you got to remember these have this pin on the bottom, and that will go right in the slot. So the bearing block sits real nice on the table here, and this 1-inch parallel is just like perfect fit as far as everything goes to keep this pretty much in the center of the slot and up tight against the fence. All right, we're bolted down. I just put a washer on this side, that way it's pushed up flush there and just a few thousandths down here with a shim pushing on it. And we're tight with our parallel and our fence. Edge find the block and then come in. Now we're just coming over here to split the difference on the seam with we use no wiggler as a pointer, and it's right there. No, it came out really good. I'm really happy with that, and that will secure those bearing shells in place really well. They won't be able to rotate. And for the top, we'll do the same thing to the top. This is how I cut the groove here for the grease groove. These are the two top halves. Now these are both bored to the same IDs, and I was able to put them together with the 50,000 shims, and they were within just about 2 thousandths of being round. So they came out really nice there. And then I lined this up in the 4-jaw, and I went in with the grooving tool I used before, this little insert grooving tool, and set 2 stops on the ways. This is the 2 stops I used. I used a digital readout on this side for one side of the groove, and then I used this as my other stop on the other side. So this way I was able to cut both of them at the same time. And we're going to take it out. See how we did, and we'll go over on the and take a look at them with it together. I'll have to kind of clean up the burrs a little bit, but those came out nice. Obviously the holes were not in the same place on the casting. You can see how I'm on the edge of this one. This one I got clearance on both sides, so it wasn't the casting hole is not in the same place, or not even very close, about 80 thousandths off it looks like. That one goes there, and this one goes here. There we go. That's how they'll go together. Grease groove on the top, and like that. And then we'll be filling those other grooves with felt. And there'll be shims in there. So we'll call those. We're going to call those done, and we'll get them fitted up on the journals, and we'll get all that shown, and I'll get some shims made and all that for the next video. But for now, I think we'll call these bearings complete, and I'm really happy with how all this turned out. Just real nice. Thanks you guys for watching. Please subscribe, of course, and click that notification bell so you can get notified when I get a new video out. Please consider Patreon. It really helps the channel, and it's going to help in the shop edition a lot. So please check that out. And that's about it for now. Thanks you guys. Thanks for watching.